questions from recent homeworks. We've done, what have we done? We did 9-3, or 9, yeah, 9-2, 9-3, 7-1, 9-5, 7-8, 7-1, 7-4, 7-3. So that was all the stuff in this, in test 7 here. Adriana.
From 9.3, can you do question 20, please?
20, yeah, that's probably a doozy. Let's take a look. I think we might have did this in second hour. I'll make less of a uncertain stumbling around. Yep, we did do this one. Okay. All right. So it says find the function f such that f prime of x equals f of x times 1 minus f of x, and f of 0 is equal to 1/2. So the first thing I would do here is I'm going to recast this problem using like x and y and dx, dy, and that notation to clean this up a little bit. Whenever I'm doing like a separable differential equation, I find that that's a lot more natural. So I'm just going to rewrite it this way. Everybody's good with that? So to separate this, I need to get the y's and dy's multiplied together on one side and the x's and dx's multiplied together on the other side. So I'm just going to divide both sides by y times y minus 1. Or I'm sorry, 1 minus y. And multiply both sides by dx. Everybody's good there? And now that we've got things separated, we'll integrate both sides. Now the integral of dx is real easy, right? That's just x plus c. How am I going to integrate 1 over y times 1 minus y? And then what? Can't distribute the integral there because they're both in the denominator, so you can't break it into two fractions like that. So this is a rational function, right? What were the 3 ways that we talked about, or the 3 techniques you might use to integrate a rational function? This would have been a test 6 idea. Division, completing the square to get to use tan inverse, or the third is perfect, partial fraction decomposition. Now, the division option is clearly out because the numerator is 1. There's no division to be done here. So I would be choosing between a partial fraction decomposition and a completing the square for tan inverse. If you try to do completing the square for tan inverse, you're going to end up with like minus 1 instead of plus 1. You'll have something squared minus 1. So you have to do partial fraction decomposition here. It's not clear upon looking at it. I wouldn't have been clear whether I should do one or the other. The fact that the denominator is factorable, though, is usually a good indicator that partial fraction is probably the way to go. So to do that, I'm going to have something over y plus something else over 1 minus y has to give me 1 over y times 1 minus y. So that's the equation that I need to solve a and b for. If I multiply both sides by y times 1 minus y, I get that. And then we'll distribute the a through. Okay. So if I look for my constants, negative ay plus by has to give me like 0 y's. So negative a plus b has to equal 0. And then if I look at the constants, a plus 0b has to give me 1, or just that a is equal to 1. Since I know a is equal to 1, I can plug that back in up here. So negative 1 plus b is equal to 0. So b is equal to 1. So I'm going to integrate 1 over y plus 1 over 1 minus y dy, and that's going to equal my x plus c. Scroll up here a little bit. Is everybody okay with how I did the partial fraction decomp? Could that trick show up on your test 7? Definitely could. Like these other integration techniques we've covered to this point can come back, right? You can see a partial fraction decomp or completing the square or a long division. Like those things could still happen. I'm not guaranteeing they do because everybody's test is a little bit different, or each group's test is a little bit different, but those are things that could still come up. I'm not guaranteeing that they will or they won't. Good news is that even if you didn't write any notes about how to do it, those things are still in the textbook, right? You could still look it up and like, oh yes, I just need a refresher problem to look at because I know I knew how to do this at once. I'm just kind of shaky on it still. But I can find an example and that'll be usually pretty good. All right. What's the antiderivative of 1 over y? Yeah, natural log absolute value of y. And then what's the antiderivative of 1 over 1 minus y? It's a u sub, right? So what's the u going to be? 1 minus y. So du, well, I guess negative du is going to equal dy, right? So can everybody see that? I shortcutted through some work. So I have then the integral of 1 over u. So that's natural log absolute value u. And I'll plug the u back in. So I have like negative 1 times. So again, I just kind of like shortcutted through showing some of that u sub work, but I wrote down the substitution that I made and then just went straight to the answer. This one is about as easy of a u sub as you're going to get, right? Not much there. All right. At this point, we have enough information to solve for C, or we've done enough to solve for C. Remember, we're told that y of 0 is equal to 1/2. So when x is 0, y is 1/2. That's what that's saying. So I can go and plug that in. Just write minus. Everybody's okay there? 1 minus 1/2 is 1/2. Natural log 1/2 minus natural log 1/2 is 0. So C is just going to be 0. So what I'm going to do now is, it says wants an expression of f of x, so I got to get the y by itself. So I'm going to compress those two logarithms, right? I have a difference outside the logarithms. That turns into division inside the logarithms. And then how do I cancel out that natural log on the outside there? Yeah, I use an exponent base of e. Still got that. So far, so good. I'm going to drop the absolute value and just replace it with a plus or minus on the other side. And then to get the y by itself, because it wants an expression for f, I'll multiply both sides by y, or 1 minus y. Everybody's okay there? We'll move the y over, or the other piece over with the y. Factor the y out. And then I guess we'll write it as f of x then. Woof, right? What I would say, Adriana, is that on a, like in a test situation, I would probably give you, if I gave you a problem of this level of complexity, I'd probably say you don't have to get the y by itself. Like I might add that extra direction. So like once you got to this step, or so, you'd probably be done. You've done the separation of variables piece and done the calculus steps. The rest of this is just like algebra stuff. Feel okay? Yep. Or even if I expected you to do that, that last part would be like a half a point or something of getting the y by itself. Like you've done the bulk of the work that I'm expecting you to do there. The rest of it is just like clean up kind of. Others with questions from homeworks. I know not all of us have gotten through everything yet. I'll ask again. We'll do the same thing on Friday still. But if you've got stuff that you've looked at and you want to talk about, now is a good time. You may see problems similar to these things in the homework on those 5 problems from 7.1, 7.3, 7.8, 9.3, and 9.5. So if you haven't done those assignments yet, I would make that a priority to kind of get through those, because you may see things that are remarkably similar. Okay, well, we'll come back and ask again on Friday if you guys have made some more progress since then, or circled back and realized that, oh yeah, this thing was giving me fits. Maybe I looked it up and I found the answer, but like, I don't know what the heck the answer is supposed to, like the work here doesn't make any lick of sense to me. I should probably ask about this. You can always circle back and do some more. But it seems like you guys have run to a stopping point here. Is that accurate? Okay. Then what I'd like to do for the rest of our time here is we're going to do some practice AP questions.